Hello and welcome to part 2 of relays. I'm going to be talking now about what's called back EMF, electromotive force. Now, it's not as complicated as it sounds. Basically, if we watch this meter and we energize the relay, you'll see the yellow line which is showing 12 volts to the relay. This is a scope. But if you watch closely on the meter, when I do this, you see the spikes. So what's happening is the relay coil, when you energize, is pulling the switch in, as you can tell there. But when you release the coil and take the power off, you see a bit of a spike then. It acts as a generator. This coil acts as a generator. So instead of it using power, it's now generating power. And it's sending power back down to your equipment. Now, generally as equipment goes, you probably end up damaging your equipment because voltage back, be it for a very brief period, can be quite dangerous to electronic equipment, sensitive electronic equipment. So this is quite a large relay. This shows you a bit more on how it works. Now if we take the conventional type of relays that we tend to use, we take this one. What we do to stop any back EMF is to use a diode across the relay, across the terminals of the relay. I'll show you a drawing in a second. In this case, there's your diode. You can just about, so we can move it over there. Oh, near the wires. You can just about see it there. Can you see the diode? Now that acts as a bit of a one-way street from electricity, and then it actually shorts it as the EMF comes back, and then shorts it across the terminals and stops it from going back to your equipment. So that's why a lot of relays have got a diode across. If they've not, you need to put diode across the coil. So if I show you this one, move that across, you can just about see the diode there, the little one with the white stripe on the end of it, and that is wired across the coil. Okay, so what we're going to do now is draw that. So if we go back to our original drawing on the relay, where we've got the coil and then we've got the switch of the coil. Now when we apply a negative across to the relay, it energizes the relay and then fires the relay and then turns whatever equipment we want on or off. But the negative to a relay is when we turn the power off, it will then send electricity back down, because this coil is now what's called collapsed and will send electricity back down. So what we need to do is put a coil, sorry, my apologies, a diode across here, like so. We've got this wired right first before I do it across. That's the electronic sign of a diode, like that. And that should, as a general rule, stop any back EMF going back down to that terminal 1, because when that coil collapses, this becomes a dead short and then in effect soaks up the back EMF. Obviously, depending if it was a large relay, it'd be slightly different if it was that type of relay. But the general rule with normal small relays like that, a conventional sort of diode is quite sufficient, and that's why there's a diode there. So that's back EMF. Now we've got to remember with back EMF there's other things that we use that have back EMF. Give you an example is maglocks. Generally now maglocks have diodes already built in. We've got door latches, conventional door latches, that a lot of them don't have diodes built in, and we've got to be very careful, because even if we're firing it with a relay, the back EMF from the door latch will then eventually burn out the relay. Okay, that's a basic overview on back EMF. If you've got any questions, just leave some comments on the YouTube, and thanks for watching.